Today's video is focusing on the AB 2015 exam, question number 4. This is a type 6 problem with no calculator. Type 6 is differential equations, so we're going to have to probably find a general solution or particular solution as well as draw a slope field, and sometimes a little bit extra to this. So let's start off with part A. On the axis provided, sketch a slope field for the given differential equation. So we've got, it looks like 6 points. So we're going to have to calculate the slope 6 times. So we want to calculate the slope. We'll grab one of the points like here at 1, 2, and we'll stick that into the equation. 1 for x, 2 for y, and we get a slope of 0. So at that location, we draw a slope of 0. If we repeat the process at another point, we're going to pick, we'll go with 1, 1, stick 1 in for x and 1 in for y, and we get a slope of 1. As we continue to do that through each of the points, we don't have a dot right here at at x equals 0, so we don't need to find the slope at that location. We do have a dot here, so we find the slope here, and going through the process of drawing and finding the slope for each location. So slope of -1, slope of +1, and the grading for this part is 2 points. You get your first point for the slopes where x equals 0. So you're going to look at these 3 slopes right here, and that's worth 1 point. And then your second point is looking at these 3 slopes here. And you can see that as y increases, our slope decreases, and that makes sense. As y increases, our slope decreases. So that's a good quick check. Let's look at part B. Part B, find the second derivative in terms of x and y, then do something else. So right off the bat, we're going to find the second derivative. The way we do that is by taking the derivative of both sides. So if I take the derivative of the left-hand side and take the derivative of the right-hand side, I'm going to get the second derivative is equal to 2 minus the derivative of y with respect to x. They want the expressions in x and y, and so replace dy dx with our given value for what is dy dx, which is the given slope from above. So here's our expression for the second derivative, or if we distribute that negative through, we have this. Now they ask us to then use that to determine the concavity of all solution curves for the given differential equation. So specifically in quadrant 2. So in quadrant 2, that's over here. In quadrant 2, x's are negative and y's are positive. So if we take a negative x and plug that into here, 2 minus -2 times the negative number, that's going to create a positive value, so 2 plus a number, and y is positive. So we have 2 positive, positive. The sum of 3 positive numbers is positive. So because of that relationship there, we can say that the second derivative is positive. Because the second derivative is positive, all solution curves are concave up in quadrant 2. Okay? So because the second derivative is positive, the curve is concave up. All right. Moving on to part C. Let y be the particular solution with this initial condition. Does f have a relative min, relative max, or neither at x equals 2? So at x equals 2, y is 3, because that's given to us. And the first derivative at that point 2 comma 3 is 2 times 2 minus 3, which is 1, which is not 0. Because the first derivative does not equal 0, the function will have neither a max or min. Neither max nor minimum at x equals 2. Okay? Now, if it was equal to 0, then we'd look at the concavity and we'd use the second derivative test. But because the first derivative is not 0, the curve is not flat at that location, and therefore no max or min exists. All right, let's look at the grading for those two portions. The part B is worth 2 points. You get your first point for correctly finding the second derivative, and then you get your second point for stating why you know that all curves are concave up. So the conclusion of concave up with a justification. So the justification, I guess, is right there where I said x is less than 0 and y is greater than 0. Therefore, the second derivative is greater than 0. And then part C, this is worth 2 points. The first point comes from, did you consider the first derivative? So if you evaluated the first derivative at that location, you'll get 1 point, and then the conclusion is worth your other point. All right, let's move on to part D. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So I'm going to grab another piece of paper to work on this part. All right, so if y equals mx plus b is a solution to the given differential equation, then the derivative of this will be the same slope. So if I find dy dx for this, it's going to be the same as the dy dx given. So these two have to be equal to each other. So we can write the expression m is equal to 2x minus y. Now furthermore, now that we know this is true, if this curve is a solution, then mx plus b can be substituted in for the y. So 2x subtract mx plus b, because that is what y is equal to if this is a solution. All right, so let's clean this up a little bit. 2x minus mx minus b, and we can factor, we can factor an x out here. 2 minus m, subtract b. All right, so at this stage, if this is a true expression, we have a constant on the left and a variable on the right. In order for the variable to be canceled, 2 minus m has to be equal to 0, or else our variable expression would continue to be variable and we would have a variable on the left. So we're able to conclude that 2 is equal to m. So if 2 equals m, then we get the expression this, and we get 2 is equal to 0 minus b. 2 equals negative b. Therefore, negative 2 is equal to b. So negative 2 is equal to b. And there is our solutions for m and b. Okay, the 3 points that come from this. Did we find the derivative of mx plus b? So finding that relationship right there is worth 1 point. The second point comes from setting the slope of this equation equal to the given slope. And then our third and final point, and it is a tricky one, is to grab the values for m and b. All in all, I would say this is probably a more challenging type 6 problem, specifically given part D. There wasn't a solving for a particular solution, which usually grabs the easier 5 or 6 points of these problem types. But a good problem nonetheless. Okay, thank you for watching. Be sure to comment, like, and subscribe. Have a good day. Bye-bye.